Okay, so the goal of this little lesson is to think about the complementary angles of our trig ratios. So if you think back to like year 8, you think about complementary versus supplementary. Complementary means things that add up to 90 degrees. So there'll be a few insights we can have here. I wanted to start with a nice simple example. If we have this triangle over here, and we know that, let's say this angle in here is 30 degrees. And so cosine of this angle is equal to adjacent over hypotenuse. So that's going to be root 3 on 2. So cosine of 30 equals root 3 on 2. But the complementary angle is this angle up here. And this angle up here, given that this is a right angle triangle, and this is 30 degrees, this must be 60 degrees. This would be 60 plus 30 plus 90 would give us 180. This angle here must be 60 degrees. And so if we think about sine of that angle, so sine of 60 degrees is opposite over hypotenuse. So that's root 3 on 2 as well. So if we think about that just all together now, so we're saying cosine of 30 degrees equal to root 3 on 2, and sine of 60 degrees is equal to root 3 on 2. Now that's obviously no coincidence. And one thing you can start to think about is the wording sine and cosine. So the co in cosine means the complementary of sine. That's why it's called cosine. The CO means complementary. So sine and cosine, you can see complement each other in that way there. So what I wanted to do as well is explain what on earth's going on with the rest of this diagram. And believe it or not, it's not finished. There's more to come. But hopefully what we're aware of to begin with is we're going to start by looking at this sort of brown triangle here. Hopefully we know that we can define the coordinates on the unit circle in terms of the angle that's created here. So this angle here we're going to call theta. And hopefully we're aware that, the x coordinate can be represented with cosine of that angle because it's adjacent over hypotenuse. And if the hypotenuse has a length of 1, then it's just this length here, from here to here. And then sine of the angle, which is just this length here. Okay, and then what we want to start to do is start thinking about the complementary angles. So if we start to come up here to have a think about it, it says cosine of pi on 2 minus theta. Okay, so basically what we're doing is we're looking at this blue triangle now. And you can imagine if I take this point here and sort of shift it onto there, that's essentially all I've done. I just needed to show 2 triangles to make it easier. But basically I've just taken that point and I've moved it there. And so what we're saying is, all right, cosine of pi on 2 minus theta. So that's the complement of that angle. So say this angle was 30 degrees, then this angle created here all the way around would be 60 degrees. Okay, and similarly, we've got the complement of the angle, so pi on 2 minus theta there as well. Okay, now what we need to do is we need to think about these triangles. These triangles are congruent triangles. They all have a hypotenuse length of 1. And I want you to start thinking about what's happening to this length. If you notice this length here on our brown triangle becomes this length here on our blue triangle. And similarly, the base length here, this length here, is the same length as this. So we can see that the cosine of our complementary angle, pi on 2 minus theta, is equal to sine of our original angle. Okay, and similarly, sine of pi on 2 minus theta is equal to cosine of theta, again, just by sort of looking at the side lengths and how they sort of move as you go around the circle. Okay, and then we come over here, and now we're talking about, from the y-axis, so pi on 2 is 90 degrees here, and then we're adding theta. So, we've got theta here, we get to pi on 2, then we add theta. Okay, so that's, pi on 2 plus theta gets us all the way around to here. Okay, and then basically, the same thing's going to happen again, or we can think about it in a similar way. This sine length here as we move it around, this length becomes this length down here, is equal to that length down there because they're congruent triangles. Okay, and similarly, this length becomes this length here. But once you know what's going on in this first quadrant, in the second quadrant, you can be aware that you're just going to make the cosine, what was the cosine value, negative. So it's going to become negative sine theta, and it's going to become positive cosine theta. So yeah, to summarize, we're saying cosine of pi on 2 plus theta equals negative sine theta, and sine of pi on 2 plus theta equals cosine theta. Okay, and then obviously there's the same things hold in quadrants 3 and 4. Once you understand what's going on in this first quadrant, you just need to understand where the x values and the y values are positive and where they're negative. So we know that in quadrant 3, the x values are negative and the sine values are negative. So, our x coordinate got transformed from cosine x to sine x, or from cosine theta to sine theta, and then down here it's going to be negative, so it's going to be negative sine theta, and then it's going to be negative cosine theta. And, again, this side length here became this side length here. And that's, we're doing this all from the y-axis. So it's 3 pi on 2 minus theta. So all the way around here. So if we started here, went all the way around, that'd be 3 pi on 2 minus theta. So that gets us to this point here. Okay, and then similarly, the last one is we know in this quadrant that the x coordinate is positive, but the y coordinate is negative. So it's going to become sine theta, negative cosine theta. So we get cosine of 3 pi on 2 plus theta equals sine theta, and sine of 3 pi on 2 plus theta equals negative cosine theta. Okay, now you're probably wondering what's going on with tan. So let's have a think about tan. Okay, well, again, if you can understand this top line, this line here, everything else should fall out of that, because tan of pi on 2 minus theta, again, your tan values are just your y values divided by your x values. You're going to take cosine divided by sine, which is the reciprocal of tan. So remember, tan is sine over cos. So cos over sine is the same thing as 1 over tan. Sometimes we call that cot, or the cotangent of x. And similarly, in this quadrant here, I've done the full working out, so it's a bit clearer, hopefully. But tan of pi on 2 plus theta, so that's going to get us around to here. Again, we're taking cosine of theta divided by negative sine theta. That negative, it doesn't matter where the negative is, but for clarity's sake, it probably should have been on the bottom, but doesn't make a difference. So that's going to become negative 1 on tan x equals negative cot x. Okay, in the second quadrant, so it's negative cotangent of x. Down here, they're both negative cos and negative sine, so that becomes positive the cotangent of x. And then in the last quadrant, that should be negative. That should be negative. How do I edit that? That should be negative cot of theta, even would be better than. Okay, so they are all your complementary trigonometric ratio identities. Again, the key line is you understand this first one here, because then everything is symmetrical from there. And like all things in maths at the moment, anything from the y-axis is harder than stuff from the x-axis. So we'll talk about the symmetry properties in the supplementary case. So that means from the x-axis in this lesson as well. So yeah, hopefully that's useful.